So looking now at the availability of the system components, if you look at the transformer, I have considered 1500 years, mean time between failures. So I took something in the middle, and I was considering this 4 months period, the MTTR, mean time to repair. Then I'm getting availability 0.9998, so 99.98%. If I take the VFT and I would consider 10 years MTBF and 6 hours MTTR, time to repair, then I'm getting 99.99%, so even higher than the transformer, the availability. Of course, this is a calculation example, but it should just illustrate the ratio and especially the fact that we should not just look at the MTBF. I mean, the MTBF is just telling you what is the probability that the failure happens. But the other side is like a coin, it has always two sides. One side is the probability of the failure. The other side is the consequence of the failure. So basically for the transformer we can say the probability of a failure is very, very low, but the consequence can be very dramatic. For the VFT, the probability of the failure is higher. So during the lifetime, if it's a lifetime of 20, 25, 30 years, it's likely that you will experience a failure, to be open, to be honest. But in most cases, the failure is minor, can be fixed very quickly. It can be a failed semiconductor that can be replaced almost immediately, or it can be leakage in the cooling circuit system. It can be something. The repair is normally fast. So this is always important to consider. I don't want to make any competition which component is more reliable or less reliable, which one has higher availability. What I want to say is just that the MTBF is not the only figure you should look at. This is a little bit taking the availability or taking it out of the context and just comparing two figures. This one is higher, this one is lower. But you should understand the availability, how the definition works, and thinking just simply practically, what does it mean for you when the failure happens? What are the consequences for your business?